We're going to look at some more dividing by fractions, but we're going to look at some problems that are a little bit more complicated. Let's look at 5/3 divided by 5/6. Now when you first look at that, that actually looks kind of intimidating because you have a fraction divided by another fraction. Before we looked at a lot of whole numbers and single numbers divided by fractions. So here we have 5/6 on the number line, and here we have 5/3. So the real question is, how many times does 5/6 fit into 5/3? And that's what we're going to investigate today. And just like the last lesson, what we want to do is find a common denominator between 5/3 and 5/6. Denominator being kind of like the, a fraction is basically parts to whole, and so we want to figure out how we can divide them in the same number of pieces, right? Total pieces, the whole pieces, if you want to say. So to get 5/3 to look like 5/6, we're going to multiply both the top and bottom by 2/2 to have a common denominator, and that becomes 10/6. So really 5/3 is the same as 10/6, and now we can more easily see how 5/6 fits into 10/6. In fact, if you look on the number line, it's halfway between 0 and 10/6. So therefore 5/6 fits into 10/6 two times. There's one hop, there's two hops. So again, the key is in finding a common denominator, and once we figure that out, we can actually just divide the numerator. So 10 divided by 5 gives you 2, and therefore 10/6, which is the same as 5/3, divided by 5/6 gives you 2 back. Notice that, just like in the last lesson, we ended up multiplying by 2/2 to get the top numbers to be the same. Keep that in mind as we look at the proof for this in here in just a minute. Okay, in this we have 7/4 divided by 1/2. So the question is, how many times does 1/2 fit into 7/4? Again, this is a little complicated because if you draw these on the number lines, 1/2 is between 0 and 1, and 7/4 is in between 1 and 2. How in the world can we figure out how many times it fits in there? Well, again, the key is to finding a common denominator between the two, which by now you should be able to see is 4. So we're going to take 7/4, we're going to take 1/2 and turn it into a denominator of 4, so we multiply the top and bottom by 2/2. So now we have 7/4 divided by 2/4. And again, what we can do is take the numerators and divide. So 7 divided by 2 gives you 7/2, which is 3.5. Let's go ahead and look at the number line. Again, here's 1/2, and if we convert it to a denominator of 4, it's 2/4. So now we can clearly see how many times 1/2, which is the same as 2/4, fits into 7/4. We have 1 hop, 2 hop, 3 hops, and a half, which is exactly the same as 7/2. So here's 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. That's another way of looking at it. So again, all you do is find a common denominator and then divide by the numerators to get your final answer. 7 divided by 2, which is the same as 3.5. Let's look at another one. If we have -3/2 divided by -1/5, how many times does that fit into it? In other words, what's the quotient? Well, again, when we draw this on the number line, and I forgot to put my negative signs here, give me 1 second. This should be -2 and this should be -1. Whoops. Try that again. Okay. So how many times does -3/2 how many times does -1/5 fit into -3/2? Well, that's really hard to figure out without finding a common denominator, right? Especially it's hard to visualize. So let's go ahead and find a common denominator between the two. For this particular instance, we have to, we can't just multiply one fraction by two numbers and be done. So we have to multiply this fraction by 5/5 and this fraction by 2/2. That's exactly what we're going to do. Multiply -3/2 by 5/5, multiply -1/5 by 2/2. Now they have a common denominator of 10. Now we can clearly see if we divide by the numerators, -15 divided by 2 gives you, -15 divided by -2. I'm going to need to move that negative real quick. There we go. -15 divided by -2 gives you +15/2, which is the same as 7.5. Let's take a look at the number line. We took, first of all, we took -3/2, converted it to -15/10. Then we took -1/5 and converted it to -2/10. So these are the same number. These are the same number. Now we can easily divide this. Take this and divide by this. So in other words, how many times does this fit into that? Let's count. 1, 2, 3, 4, 5, 6, 7 and a half, which is exactly what we got over here. Or you can think of it this way: if it's 15 halves, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 15 halves, and a half being, a half of the negative 1/5, which would be negative 1/10. If we do 15 of that, we end up where we started, but again, that's just 7.5. Okay, now what we want to look at is kind of a proof of what we just did. So first of all, what we're going to do is think of a general number a over b. It could be anything, right? 2 over 3 or whatever. And then another number c over d. So to find common denominators, we have to multiply a over b times d over d, and then multiply c over d by b over b. In other words, we're kind of multiplying each fraction by the other denominator to find a common denominator. So they both have a common denominator of b over d. B times d. Now we can take a times d and divide by c over b. And what's cool about that is then we can then split it or kind of rewrite it. See, division can be just rewritten that way, AD divided by CB, and that can then be rebroken up into A over B times D over C. And that's because that's how you multiply a fraction straight across. You can do the reverse. So we've shown that A over B divided by C over D is actually just A over B times D over C. So what we're really saying is we're taking the division sign, first of all, we're changing it to multiplication. Then we're taking the C over D and we're flipping it, and it becomes D over C. And that's why sometimes you'll hear keep, change, flip. Notice that the original fraction stayed the same. We kept it. The division sign changed to multiplication. And let's use a different color there. Change to multiplication. And we flipped. Let's use this color. We flipped the fraction. Keep, change, flip. That's a proof as to why that works. Let's look at one that's a little bit more detailed. So we have A over B divided by C over D. We're going to multiply this fraction by D over D. To start with the common denominator, we're going to multiply this fraction by B over B. So now we have a common denominator of BD. Okay. And you can kind of read some more details on that proof. So let's see here. Yeah, so now they have a common denominator of BD. So now we can just multiply the numerators. AD, let's move up here a little bit. AD divided by CB, because they have a common denominator, just like we did in the previous examples where we divided by just the numerators. Okay, and let's move down here. Okay, so now we can divide by the numerators. But CB is just BC because the multiplication order doesn't matter. So now we have AD divided by BC written in a different way. Then we can resplit the fractions up. So we will actually have A over B times D over C. And that's it. So we've proven that we started with A over B divided by C over D. Well, that was a little fast. Okay. And we ended up with, so we started with A over B divided by C over D. We ended up with A over B times D over C. So this flipped, and this changed to multiplication. And that's why it works. So we are dividing fractions by fractions, and let's go ahead and move right into first official example. We have 10 over 7 divided by 2/3. Well, in this case, obviously they need a common denominator and everything, but the thing is, we've just shown kind of a shortcut. We don't have to multiply, we don't really have to find a common denominator as much as all we have to do is change the division to multiplication and flip the fraction. That's the beauty about proof. Once you prove something, you can kind of use the shortcut without having to go back and do the long way. So that's exactly what we're going to do. Change that to multiplication and flip this fraction. And yes, the original fraction stayed the same. So that's why we say keep, change, flip. But again, I can't emphasize the importance of why it's true. I mean, it's one thing just to say, well, my teacher told me so. It's another thing to understand why it's true, and that's why I show you this way. It will help the concepts stick in your mind, trust me. Okay. So now that we've multiplied by the reciprocal, which is step 1, multiplying by the reciprocal, now we can kind of cross divide. So we have, because again, the order of multiplication and division doesn't matter when you're multiplying fractions. And so we can go ahead and divide the 10 by the 2, cancel that out, and that gives you 5. And then we can't cross divide the 3 and the 7, so we just multiply straight across. 5 times 3 gives you 15. 7 times 1 gives you 7. Final answer that goes inside the box is 15 divided by 7. Alright, next example. We have 5 over 6 divided by 1/4. This one is actually just kind of asking to fill in the box. So notice that the division changed into multiplication, so therefore we must be doing what with the second fraction? We must be flipping it, right? If you flip 1 over 4, it does become 4 over 1. Whoops, I did not mean to do that. But more simple than 4 over 1 is just 4, right? So you can go ahead and just simplify that one out. And that is a misprint, so we'll change that. Okay, so we had 5 over 6 times 4 over 1, which gives you 5 over 6 times 4, and that's what goes inside the box. Okay. Now we have b over c divided by m over n. Alright, so b over c divided by m over n. So what we're going to do is follow the same steps. We're going to keep the first fraction, change this to multiply, and then flip the second fraction. So what do you think goes inside the box? If you said n over m, you are correct. Pretty simple, right? Alright, going back to a more, where we have to follow step by step, what you do for every problem, but in this case we're going to show every step, which we kind of did in the last one. We're going to do it line by line. Okay, so simplify this. So 5 over c divided by b over 10. So we're going to take the division, change it to multiply, and then we're going to multiply the flipped version, or the reciprocal, of b over 10, which is 10 over b. Then we're going to multiply straight across the numerator to get 50 on the top, multiply the denominators to get cb, which is the same when you simplify, bc. Final answer then that goes inside the box is 50 over bc. Alright, so we have m over a divided by k over l is equal to, now, what times L over K? So notice again, this changed to multiply, and this was flipped to L over K. So if it's keep, change, flip, notice the keyword keep. Okay? So the red is the change and the pink is the flip. So the purple must be the what? Must be the keep, right? Stayed the same, so therefore it's m over a. I could see how you could get confused and put a over m, but again, the first fraction stays the same as we showed before. Okay, we're going to do several more here. Let's go ahead and take a look at this one. This is 5 over a divided by what gives you 5 over a times x over square root of 3. Now notice again that these changed from division to multiplication, and if these stayed the same and we kept them, then we must be talking about what? Keep, change, flip. So therefore these two must be flipped from one another. And what's the flipped version of x divided by the square root of 3? It would be the square root of 3 over x. Very simple. Okay, next one, simplify negative a over 10 divided by a over 6. You first look at this one, and it kind of looks really simple in the fact that there's two a's, and we're going to see how it actually simplifies. So we're going to multiply by the reciprocal, so that's going to change to multiply. This is going to flip. So we have negative a times 6 on the top and 10 times a on the bottom. But notice if we have an a up here and an a down here, we can cross divide like we talked about before. So we can divide the a's. Now notice though that the negative sign that's out front stays the same, just the a's themselves cancel. So we actually end up with a, and actually I just kind of showed that you can write that as negative 1 as well, or you could just put the negative sign there. But anyway, negative a over a is negative 1, so we'll just write it that way. But anyway, yeah, you could just put the negative sign there, and it could just become negative 6. But anyway, it's negative 1, so negative 1 times 6 is negative 6. You can think of it that way too. Now you have negative 6 divided by 10, and we can actually simplify that. Divide both the top and bottom by 2 to get negative 3 over 5, and therefore what goes in the box is negative 3/5. Alright, let's take a look at this one together. We have pi over e divided by 2 over 3. We're going to keep the first, change this to multiply, flip the second, multiply straight across. We're going to have pi over 3 on top. Sorry, pi times 3 on top, e times 2 on the bottom. And remember, the constants always come out first. And yes, pi and e are both constants, but remember that normal constants is what we call them. Come before the constants that look like letters or variables, even though they're actually constants. So we're going to pull the 3 and the 2 up front. And then we can get rid of the multiplication sign. Final answer. See if I can circle that a little bit bigger. 3 pi over 2e, which is what's going to go inside the box. So that's it. We are simply taking when you divide fractions, you simply do nothing to the first fraction. Okay? You change the division to multiplication, and you multiply by the reciprocal, or you flip the fraction.